Okay, so we've done 2 of the 3 calibrations that we need in order to use the machine. The last one is what's called the probe calibration, and that's where we actually calculate the area function of the pyramid indenter that we're using. And we do that by making indents again, like we did on the aluminum sample, where we use a standard sample of fused quartz. And then there's another one of these standard samples. It's in here on the stage, just like the aluminum sample was. And you can see it's just a piece of quartz that's glued to another one of these magnetic mounting pieces. So what we'll do is we'll take this, put it on the stage somewhere until it snaps down.
You took already the aluminum sample, right?
Yeah, the aluminum sample I just put over here to the side. And so here's the quartz sample. We're going to find that with the, we could just put it there, put it right where it was, and find a different, create a different boundary. So that's what I'm going to do. Is I put it right underneath the light of the microscope. I'm going to go over here and find it in the video window so that we can do the procedures again. So we're going to, once again, we got to focus in on an area in the quartz sample, and this is the quartz is a little more difficult to focus in on, just because it's transparent, and finding an area or getting a good. That's it right there. It's kind of tough to discern. But the easiest thing to look for are kind of surface defects or darkened spots. And so right here, when these become a little clearer, that's when you know when you've gotten a pretty good focus. So we'll go in and out, and you can see right there we got a pretty good optical zoom. So we're gonna find a space on here that's relatively clear of defects and such, because we're going to put down quite a few indents. So this looks like a pretty good area. There's not a lot of defects that I can see. And we're going to be putting these indents. We don't have to find these later because we're going to record the data that's recorded. So it's not a visual thing. But so we're doing that. We're going to create a different boundary. So it says we successfully created the new sample boundary, sample 99. That's good. We're going to remember that is sample 99 that we created a boundary around.
Can you tell us if we change the zoom factor, what's going to happen, or what?
Yeah, if you change the zoom factor from the optics calibration, it's going to lose its sense of where it is in Z, because you will be zoomed in closer or further away, and so the machine won't really remember where it is in Z axis. So if you try to then start a procedure in which you're trying to put indents down, it's going to step towards the sample, but it's not going to know when it's actually finding that sample, and it might run into it before it thinks it should, and then you're going to sense some excessive force in that way. And like I said, there's a lot of good safety protocols built into the software that don't let you do that. So if you start to sense an excessive force, it's going to stop the whole shebang, and it's going to make you start over. So you want to have that zoom factor on the same zoom factor that you had when you calibrated the optics. One thing you might remember from the previous calibration, and after we did the optics calibration, it told us that all samples need a quick approach, except for the boundary that we did the optics calibration in. Now when you do a quick approach, it steps down slowly until it just touches the surface to get a clearer idea of the Z height that it's at in that thing, and that substantially reduces your testing time. Because when you're doing your indents for the first time, if you don't do the quick approach, it doesn't know exactly where it is in Z, so it has to step very, very, very slowly so as to not run into the sample. But if you do a quick approach, then it knows when it can start. It can know where it can move freely, things like that. So we've created a new boundary here, and we're going to do a quick approach. We're going to click quick approach, and it's just It's going to say, from this current optic position, a quick approach will be executed, and we'll say OK. And that takes a minute or two for that to do, so we'll come back here in a second.